So far we have been looking into various measures of statistics. So the next measure of statistics that we're going to look at is the measure of relative position. Here we're going to talk about quartiles. So basically what happens is this: when you have data, you can actually make those data into 4 different segments, and that you can say as quartile. So this is very valuable for us. The reason that it is valuable for us is whenever we have lots of, let's say the scores of my class starts, let's say, hopefully it is not the case, everybody gets 100% in my class, but let's say we have a class where the lowest score is 10, the highest score is 92. Okay, now if I want to make it as, hey, these are excellent students and these are good students, these are average students, and then these students I need to see how to make them better, the last set of students. Let's put it that way. So if I'm going to have that, I have 4 different buckets. I can make it into 4 different segments, right? Then I can see which students are where so that I can focus on some of the students in a real class. In an online class, it is tough to do that, but in a regular class, I can do it. In a hybrid class, I can do it, but not in an online class, fully online class. So it's going to be very tough for me to pick out certain students and just do it for them. In a hybrid class, that is in my class, my regular class, I'm going to have a regular class and I can do that. So quartiles are very helpful. So let's look at what is a quartile and how to come up with these quartiles. Okay. So the first thing that I would like to do is to find out these quartiles. Let me make my pen red in color so that it'll be easier for me. So quartiles are measuring the relative position of data values by dividing the data into 4 equal segments. This is the idea, 4 equal segments. So I'm going to make it into 4 different segments, and I'm going to see which data falls into these 4 different segments. Let's say I have a data, the data that I've used before, 9, 5, 3, 10, 14, 6, 12, 7, 14. These are some data that I have. Okay. Now, the first step to do this 4 equal segments is that I'm going to arrange the data in an ascending order. That means the 3 comes first and 14 comes in the end. So I'm going to do it in an ascending order. So I'm going to have 9, 5, 3, 10, 14, 6, 12, 7, 14 as 3, 5, 6, 7, 9, 10, 12, 14, 14. So this is my first step. My second step is I'm going to find the median. How do I find the median, basically? How many data I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can have 4 and then 4. So my median is going to be 9. So that is my median. Okay. So I got my median of the data set as my step 2. Step 3 basically is I'm going to take this as the lower segment and this as my higher segment. Okay, so lower segment and higher segment. Now I'm going to do the medians of these. So my 3, 5, 6, 7 is my lower segment. 3, 5, 6, 7 is basically, it's an even data set. So my median is going to be 5.5. That is 5 plus 6 divided by 2. That is 5.5. Then my higher half is going to have 12 and 14 as the median. So I'm going to have 12 plus 14 divided by 2, which is 13. Okay. So now I have 5.5 and 13. Now I can see the quarter. My first quarter is going to be less than 5.5. My second quarter is going to be greater than 5.5 till 9, which is my the median of this entire population. That is my second quarter. My third quarter is going to be greater than 9 and less than or equal to 13. And my fourth quarter is going to be greater than 13. Now I can place my points wherever it is. For instance, I can say if this is my first quarter, second quarter, third quarter, fourth quarter, then I can say my first data 3 is going to be in my first quarter. 3 and 5 are going to be in my first segment of the first quarter, and 3 and 5 are the lowest quartiles, whereas 14 and anything greater than 13, so 14 is going to be my highest quartile, or the fourth quartile. Okay, so I can separate out these things according to quartiles. And so quartiles are measures of relative position. It's pretty easy to do that, right? So you should be able to do this. The second one is what is called a z-score. This is actually a very important one, and this uses standard deviations from the mean. So basically, we are talking about how many standard deviations from the mean is the z-square. A measure of how many standard deviations either below or above a population or a sample mean is the z-score. A z-score tells you where the score lies on a normal distribution curve, where it lies, where this point lies. Okay, where the score lies. A z-score of 0 tells you the values is exactly average, while a score of +3 tells you that the value is much higher than the average. A z-score of 1 is 1 standard deviation above the mean. A z-score of 2 is 2 standard deviations above the mean. A score of 1.8 minus is minus 1.8 standard deviations below the mean. So basically, positive numbers are above the mean and negative numbers are below the mean of the z-score. Okay, so one of the things that we can do is to look at the z-score. Look at this.
This is Stephanie from statisticshowto.com. In this two-part video, I'll be showing you what a z-score is. I'll also be showing you how to calculate it. If you already know what a z-score is, you can skip ahead to part 2 by clicking on the link showing up right now. Let's say we have a normal distribution curve that's more familiarly known as the bell curve. I'm going to have some mean. Let's say I have a mean of 100. And then I'm going to have some observation. Let's say I have an observation of 125. What I want to know is how far away is my observation from the mean? What is the distance? Well, in statistics, z-scores are measured in standard deviations. And here's another bell curve with the standard deviations put in. If you're not familiar with standard deviations, you may want to click on the link in the description field. That will take you to a short article explaining what a standard deviation is on our website, statisticshowto.com. Right now, we're interested in standard deviations and how they relate to z-scores. A z-score of 0 tells you the observation is bang in the middle right here. This is the mean. A z-score of +1 will tell you a score is 1 standard deviation above the mean. And a z-score of +2 tells you you are 2 standard deviations above the mean. So that's what a positive z-score tells you. You're a certain number of standard deviations above the mean. And we can go back the other way too. The z-score of -1, it tells you you are -1 standard deviations below the mean. And -2, -3, and -4 z-scores will tell you how many standard deviations below the mean you are. So all the values to the left of the mean are negative, and all the values to the right of the mean are positive.
And you can use this, you can copy and paste this whole statisticshowto.com and then go through how to calculate the z-score and all that stuff. So let's continue on this in our quest of finding out the z-score. The next thing we're going to do is to find out the z-score of a population. So the z-score of a population basically is this value. So basically what we are doing here is example. Let's say you have a test score of 190, some test score, and your score is 190. The test has a mean of 150, so this is population, so mu is going to be 150. And a standard deviation of the test is 25. These are given to you. These are known. Okay, these are given to you. So now you can find the z-score. Now, you need to assume a distribution. Every time we do a z-score, we are going to assume it is going to be a normal curve or a normal distribution. This is called a bell curve, as we talked about before. The normal distribution of the z-score is going to be, you can find out from this equation, which is your score is 190, the mu is 150, and sigma, which is the mean, the standard deviation is 25. So the mean is 150, the standard deviation is 25, your score is 190. If you plug it in this value, you get 1.6. So your score is basically 1.6 standard deviations above the population mean. What does that actually mean? It means that on an average, you have some population, on an average, the population gets 150. This is what the scores of the population is. Population who have taken this test. So everybody gets 150. You scored 190. So basically you are 1.6 standard deviations away from 150, which is pretty good. So you are actually higher at the higher end of this whole spectra. You remember we said that one standard deviation is 68%. 1.6, two standard deviation is 95 percentile. So you're in between those two. You're pretty close to 1.6, which is close to this 95 percentile. So you're going to have this 95%. That's how the percentiles are also calculated. So the z-scores basically tells you how good you are or how bad you are compared to the people who have taken that similar test or the same test. Okay, that's what z-score gives you. Now let's look at it from the sample part of view. The sample part of view is very much like the population. Only thing we do is that we change the denotation. We denote the mean by x bar, and then this is the mean, and then we do the standard deviation. We say yes. Okay, so that is a basic difference. So now let's say you have a similar thing like 190 is your test score, and you have a mean of 150 and a standard deviation of 25. So this is basically the same as this, right? Same as what we did before as a population. This is what happens. Now, actually, your score will be correct. This is going to be the same. Okay, but you're between the sample and the population, the standard deviation might change, the mean might change, but in this case it did not. So that's why you end up with 1.6 as the number of standard deviations above the sample mean. So here, since we did not have a change in the mean and standard deviation from the population, the sample is pretty much the same as the population. That's the whole idea of looking at it. Okay, so we can see that z-scores are very important, and z-scores are going to be helpful to you to find out where you stand with respect to others. That is the whole idea of the z-score. We will go to module 6 after this.